Hello, everyone. I think this is working. Bring the background music down a little bit. All right. Happy Thursday. Take my headset off here. So, today we're going to be talking about the fundamentals of flight. A couple of just heads up sort of announcement type things to kick us off here. If you're joining for the first time, this is a series of lessons along the private pilot airman certification standards, sort of teaching you from the beginning with no knowledge all the way through kind of flying the plane as a private pilot might. There's a big disclaimer on all of that, which is that flight instruction is really a type of activity that's best done one-on-one with a flight instructor who will know you best and will be able to work with you on the things that you need the most help on. So big grain of salt if you're tuning in on Twitch. I'm hoping that you learn some useful tips about how to fly better, maybe something you can apply in like a Microsoft Flight Simulator. But the goal here is not to then go out and actually fly a plane. If you do want to do that, which I highly encourage, I think that's obviously a wonderful thing, your local airport will have most likely some sort of demo flight you can do either through a flight school or a local CFI who works there. So if you find your nearest airport and just kind of do a little bit of Googling, getting hooked up with a demo flight is a great way to see if you want to go and learn for real. The lessons that we're going through roughly model what the lessons you might take actually would look like. And I'll try and call out things that don't work super well in the simulator. Today's actually going to be a pretty heavy day of that sort of stuff. There's a lot of things where it would be a back and forth between the instructor explaining something and demonstrating it, and then the student kind of trying it themselves and the instructor correcting things as we go. So the flip side of that means also that although I've booked off about 2 hours of time for today's lesson, I expect it may go a little short because in a real lesson covering this content, there would be kind of this back and forth with the instructor or with the student then practicing these basics and really starting to master them. And so, or at least getting an initial sense of how to use them. Of course, the fundamentals of flight are things that we use in every flight that we do all the time. So they keep coming back up again and again, unsurprisingly. Okay, let me make sure I'm not missing anything in my intro. Oh, this is the second stream that I'm doing along this series, so there's still a couple of bugs here and there that I'm working through. If you notice anything weird, especially things like audio level are always a little tricky, feel free to message them in the chat. I always appreciate the feedback. And of course, feedback on anything in general. More environmental heads up. I am in the California Bay Area, so near San Francisco, and we are currently getting torrential downpours and lots of storm weather. So there is a non-zero chance that we lose power through the stream. So if I suddenly disappear, that may be why. The other part of that is that my wife is work from home today, and we also have 2 foster puppies here, and then my 2-year-old dog. So there's a non-zero chance that there's just noise in and around the house if things are going on. I'm lucky in that the 2-year-old puppy has blessed me by sitting next to me for this stream, so that's kind of nice. But we'll see. Maybe he'll get up and move around a little later. Another piece to mention is the lessons are meant to build on each other, so we'll have different building blocks kind of covering, of course, the fundamentals today, and then later lessons will build on these fundamentals. I will try and have each of these streams be useful to someone who's just tuning in periodically, so if you can't make every single one, that's totally fine. If you do want to watch them, they'll also be up on Twitch later, so you can always catch up offline and then join for a future one. But I will try to make each of them at least semi-encapsulated as best I can. Again, if it was a one-on-one instructor working with a student, then there would be more of a back and forth and really calibrating to where the student is struggling most or where they're excelling most and tuning to that. What I'm trying to do is just sort of a general overview of each of these different topics. I guess the last thing to mention that's sort of fun and new for today is I had mentioned last time if you had any questions to post in Discord. So there's a thank you for being my co-pilot Discord that you're welcome to hop on. Love to see you on there. If you have any questions or feedback or other things that you want to talk about, that's a great place for it. To help make that easier, today I added a chat bot. And so if you type in !Discord, it'll give you the link to Discord, or !add-ons. Then that will tell you the Microsoft Flight Sim add-ons that I'm currently using. So for instance, I have a Palo Alto one, which is giving me these T-bars. So if you're interested in that sort of thing, that's a good way to do it. All right, checking the chat here. What's up, Scott? Yeah, that's right. No, just the 2-year-old puppy. Yeah, and he definitely acts more like a teenager, so it's a little bit like having like a 15 or 16-year-old around the house, which is sort of funny. Get to see their personality develop real quick. All right, three other bits of follow-up from the last flight. So I mentioned that if anything comes up in the flight that are sort of questions that you may want more answers to, or things that I don't know off the cuff, that I'd talk about them in the subsequent flight. So today there's 3 to follow up on. One piece, and I will just do this now. So if I hop outside the plane, when we were doing our, I forgot I can't do it that way. When we were doing our walk around, I was talking about this back part of the plane. Behind the fuselage is this empennage. So I was struggling to remember the pronunciation for this kind of, it's the whole tail assembly. So it's this whole area is the empennage, which I will, going forward, remember as similar to pronouncing empanada, but with kind of like a French twist at the end. So empennage. Another one that came up is we were talking about the registration period. So if you remember, aircraft need to have one of the 4 required documents is the aircraft registration. You'd typically find it kind of down in the pocket here, not modeled in the sim. That registration is renewed every 7 years now. So they actually just changed that rule this month. So it is, at least my understanding of what was essentially a federal law change, but reading through it, it seems like the 30th of this month or the end of this month, it will go into effect that you then have to re-register every 7 years. Like I said, I recently purchased a plane, so this will be my life pretty soon here. Previously, I believe it was 3 years. I actually just had the thing up a minute ago I was looking at. But yeah, so now it's 7 years at least going forward. And the last one to talk about is when to use which lights. So when we were getting the airplane started, I had a sort of double take of, what lights do I want to be using when I'm just taxiing around? What lights do I want to be using at different phases of the flight? And I was sort of embarrassed because I'm like, I do this all the time. What is the, like, why am I having this mix of confusion? And I went and started doing some research to figure out what was getting me caught up. And it turns out that there's the letter of the FAA law regulations, and then there's a lot of opinions about what the best practices are, a lot of them from the FAA actually, as well as then just instructors' opinions on top of that. So I found a write-up from an instructor I really like about the best use of lights. I'll post it here because it's really helpful. I also posted it in the Discord if you want to find it later. But this will talk about when to use which lights, and then I'll use that going forward for consistency. And the short version is to use the majority of your lights the majority of the time, with a couple of specific instances. So one being when the engine's running, you want your beacon on. When you're taxiing, then you want your taxi light on, your nav light on, your strobe light on. And then landing light on for when you're crossing runways or when you're taking off. When we're flying around, I'll turn the landing light off. I'll leave the other lights on. With modern LED lights, the chance of burning out a light is lower. I think it's a good habit to be in to turn off your landing light after you've taken off, for 2 big reasons I'll mention. One is if you're using an incandescent bulb, and the more wear on those, the more likely it is to burn out, and then that can be a pretty expensive replacement. So courtesy to the owner of the plane. The other piece of it is that when you're flying around at night, if you have your bright landing light on, shining on houses, it can be quite a bit. So obviously you want your landing light when you're landing, but the taxi lights at least give that same sort of visibility while you're flying around without using the super bright landing light. All right, I think that's it. So take a quick pause and see if anyone has any questions, and then we will dive right in. So today's going to be pretty different from yesterday. Yesterday was very kind of background heavy. I actually decided after the lesson, I was reviewing what went well and what went poorly, doing my own kind of debrief, and decided that for future lessons, I'm going to split this into two very distinct things. So most of what we went through yesterday is going to be pulled into future lessons because I think it got a little bit too deep for what was supposed to be a really high level kind of fun flight. So I like the lesson plan for today a little bit more. Like I said, when we talk through it, we'll look at the timelines. I think it'll be a little shorter because we won't have that kind of back and forth in the same way. But let's flip over here. All right, let's see if this comes up. Oop, I see what's happened. I'm using this cool piece of software actually called VDO.Ninja is the website. Victor Delta Oscar.Ninja. And it essentially lets you stream your camera from like a mobile device if you have it, or it'll let you stream your screen. So I'm actually streaming this Mac to my Windows PC and then Twitch streaming from there. So anyway, had to get the sharing set up again. All right, so let's dive in here. For fundamentals of flight, the objective for today is to become proficient at straight and level flight, turns, climbs, and descents, and controlling the airplane's attitude by visual reference to the horizon. So when we talk about the 4 fundamentals of flight, this is how you maneuver the airplane through all stages of flight in some capacity or another. So if you think about it, we're moving through the air in either just straight and level, we're flying at a particular set heading towards a particular point in the distance, and we're not climbing, we're just kind of at that same altitude. Or we're climbing, or we're descending, or we're turning to a new heading, or maybe we're combining those things. For today, we'll do each of them as 4 separate things, but in actual flight, every now and then you'll see like a climbing turn or a descending turn, that sort of thing. And this last bit on here, the controlling the airplane's attitude by visual reference to the horizon, is a really important piece of this that I do want to talk about a little bit more right as we get going. And this is one of those things that translates okay to the flight sim, but you can kind of see it at least in practice what it means by that, or what I mean by that. A couple references for today's flight. There's the Airplane Flying Handbook, Chapter 3, about the basic flight maneuvers. The Pilot's Handbook of Aeronautical Knowledge. Currently I have listed essentially 1 through 8. This is sort of like a superset of all the things. I actually have a to-do here for myself to go and clean these up, and really I want to get just the couple that you really need. They're all really good to read about because this will give you all the background, but principles of flight and aerodynamics of flight and flight controls really cover a lot of the meat here. So, of course, a lot of this will be covered in a ground school too, which is another important thing to do if you're going to be interested in flying. We'll talk about that for our homework. Okay. I can leave this open. For builds on, so of course it builds on the introductory flight we had, all those principles. Today when we go flying around, we'll focus more on just getting up in the air. So because we're in the sim, we can do live pause and actually talk about each of the things as we're flying. Normally we would do kind of a ground session before we go out, but take advantage of the sim when we can. Of about 1 hour of ground, 1.5 hours of flight would be with a student. This is what I would expect to do. In reality, I'm thinking it'll probably take about 45 minutes of ground, maybe 45 minutes of flight. We'll see how that pans out. Of course, yesterday I thought the same thing, and that didn't go quite as planned. So, do a quick check for the chat. Okay. Looking good. So let's dive in. So the first thing on here is straight and level flight. So straight and level flight, again, is just keeping to a specific heading, flying towards a specific point in the distance, and then also staying at a fixed altitude. One of the first things to talk about is scanning for traffic. And so, you know what? Actually, let's get up flying and and then we can start going through each of these lesson elements. I think that'll be more fun to do. So, okay, moving back over to my PC here. All right. Headphones on, check the audio. Okay. So in this case, let's assume that we've already done our pre-flight. So we've looked through all the aspects of the interior, exterior, everything seems to be working. Again, in the real lesson, each lesson you'd be doing these again with the instructor and reinforcing the best practices for those. But we can breeze through them here. Okay, so then we're going through our checklist. So we've done our pre-flight inspection. I'm going to do our you know what I'm going to do is I have to look down at my iPad for this checklist, but I can do it like this. All right, pre-flight inspection is done. Passenger briefing. So we talked about this yesterday, but there's a couple of key things you want to talk about. One of the big ones being seatbelts. So we'll talk about how to use the seatbelts. Brakes. So give a little pedal test. You can see in the bottom of the screen, I'm pushing them down. They seem to be working. I have my parking brake on now. Circuit breakers, check in. So we'd run our finger over the circuits. That's all these little white buttons here. If any of them are popped out, that's something that we would want to know about. And we could look at kind of what's happening with those and why. Electrical equipment off. So I'm scanning all of these. Again, I leave my beacon on. Kind of a personal preference, but the rest of the electronics should all be off. Avionics master switch is off. Fuel selector valve to both. Okay, so we'll look down here. So again, Microsoft Flight Sim parks this plane with it on both. In a real club plane, that's not how we do it. Oops, let me reset this here. Oh, one thing I wanted to talk about, and this is as good a time as any, is the seating position in the airplane. So I spent a little bit of time to try and get this set up so I could demonstrate what you should be seeing out of the plane. And it was really, really tricky because there's two things that I really wanted to be able to emphasize. One is that, you should be able to kind of see over the cowling and see this, a little bit of this white. Really, I wish I could get a position that's halfway between these two, but I just couldn't figure out how to get the camera to move down only slightly. So the next best thing that I came up with was positioning the camera so that it's, you can't see the cowling, so it's kind of low like this, but you can see under the wing. So that's a really nice thing for taxiing and also when we look at straight and level flight and reference to the horizon. But then if I hit the space bar, I can jump up and kind of see more of what the picture would be when you're actually flying. So you'll see me do a little bit of this going back and forth. The way to think about it is the scene that you're seeing now with a little bit of the cowl visible is what I would recommend for your normal flight. Part of the reason for that is you can see these rivet lines and they become a useful reference point for certain maneuvers. So this is kind of what I would suggest for getting your own flight set up, but you can only, the way that Microsoft Flight Sim has it set up, if you do want to use the spacebar trick, you have to kind of set up your panel like this first, and then you can press spacebar to pop the camera up one. So again, this is the standard flight thing, but then when I'm looking for traffic, you'll see me drop down. When you're flying the real airplane, this isn't as much of a problem. It's really natural to actually just kind of look over, but just because of the way that the camera works with the 2D screen. All right, fuel selector valve is on both. Fuel shutoff valve is on. Avionics circuit breakers, good. ATIS, all right. So I typically call for the ATIS. And we're actually going to do that because it's kind of fun and you can hear the real weather. So let's do two things at once. One is currently I have clear skies. It's beautiful in Palo Alto in the sim, but in the real world, Palo Alto is really ugly right now. There we go. That's what it really looks like. And that is the view outside my window right now too. All right, so we're going to call Palo Alto's ATIS and just sort of listen to it together. Don't worry too much about catching everything. We'll get more practice at that in the future. Oops. But yeah, so you can kind of get some initial practice with listening to ATISs. The trick with an ATIS, or with a METAR in general, is to learn the series of information they're going to present. And so when you listen to it, you kind of know what you need to do, or I'm sorry, what information you're hearing. So it doesn't just sound like a bunch of numbers. Thanks, up Scott. I appreciate you stopping in. Good luck with everything else. Okay, so here is the Palo Alto ATIS.
Brief. 5G node of effects for Palo Alto Airport. Use caution for activity on and in the vicinity of the airport. Hazardous weather information available on flight service frequencies. Read-back of hold for instructions and runway assignment is required. Advise ground control departure request. Advise on initial contact. Give information Bravo. Palo Alto Tower, information Bravo, time 1847 Zulu, wind 160 at 6, visibility 4, light rain, ceiling 2000 overcast, temperature 2.10, altimeter 2987, GPS approach in use, landing and departing runway 13, 5G NOTAMs in effect for Palo Alto Airport. Use caution bird activity on and in the vicinity of the airport. Hazardous weather information available on flight service frequencies. Read-back of hold for instructions and runway assignment is required. Advise ground control departure request. Advise on initial contact. Give information Bravo.
Okay, I missed a couple things, so I'm going to listen through again. Gotta redial.
More light rain, ceiling 2000 overcast, temperature 2.10, altimeter 2987, GPS approach in use, landing and departing runway 13, 5G NOTAMs in effect for Palo Alto Airport. Use caution bird activity on and in the vicinity of the airport. Hazardous weather information available on flight service frequencies. Read-back of hold for instructions and runway assignment is required. Advise ground control departure request. Advise on initial contact. Give information Bravo.
All right, great. So we have the real information. We'll use this as our communication template when we talk to Tower in just a second, so we can get some practice with the actual ATIS information. But I'm going to switch out of the rainy weather. So we're going to pretend like they said it was actually beautiful and not horribly problematic to go flying. Okay, there we go. Clear skies. Love it. With a little bit of rain still. Fun. Okay, so flip back to the flight sim here. Actually, let me talk just briefly about this. So the information they gave us, we'll talk more about what each of these mean later. The letter that you'll hear me say with information Bravo is this B. So one thing to be thinking about is, sorry, I totally lost my train of thought. So this information Bravo is what they want to know to say that you have the weather information that came out at the UTC time 1847. Again, we'll talk about all this in more detail later, but essentially they're looking for confirmation that you have the latest weather for the airport, which the latest weather is Bravo. Okay. So I'm going to put my headphones back in. I want to kind of hear how loud the engine is so we can see if we can actually hear. Okay. I'll leave it down so we can see. Back to the checklist. So we have our ATIS. Throttle open 1/4 inch. Mixture to idle cutoff. Just all the way out like that. Master switch on, both sides. Flashing beacon is already on. That's this one. Oops, there we go. Auxiliary fuel pump on, this one. And so now we're going to prime the engine. So we're looking for this fuel flow. So we bring mixture rich, and we expect the fuel flow to go to about 3 to 5 gallons. Okay, I'm bringing a little more throttle because it wasn't actually drawing any fuel. 3, 4. Okay, we want 4 seconds to that. bring the mixture to idle, turn off the fuel pump. Now it's primed. And reset the camera here. And then ignition switch to start with our right hand on the mixture to bring it in as soon as the engine catches. So hopefully this engine's not too loud. Okay. And then I'm bringing my throttle to 1,000. Looking at my oil pressure. Seems a little low. I'd hope it to be a little bit more in the green. I'm going to take that as a sim artifact rather than a problem with the airplane. Our vacuum's a little too. That might just be low RPMs. So we'll check that when we actually do our run up. Let's see how loud this engine is. That's okay. I'm going to bring it up just here. Okay. So let's talk about... Oh, sorry. And then we'll turn on our lights before we taxi. Avionics master switch on. Radio's on. So my preference is to put the ATIS information frequency in the COM2 radio. That's this one. Let's see if I can change this. You can set how much the COM dial changes this so that it doesn't have to flip through every 5. But I don't know that this one has that modeled. Okay, 135275, and we load that into the COM2. Let's see. I don't think the ATIS for Palo Alto actually gets modeled in the game. If you put in the ATIS for like San Jose, you actually would hear it while you're flying. I guess you don't hear it on the ground usually. Okay, so I'm not gonna. That's how you listen to it. Okay, and then we need to put in our ground frequency. 250. And this one does have. Oh, maybe it's in a different menu. Oops. Love it. Auxiliary, that's right. Okay. So if you go in here, you click this cursor to select it. Okay, there we go. So this will change the channel spacing. So now if we dial this, hopefully now if we dial this. Okay, yeah, there we go. So it's every 2 instead of every 0.8 or whatever it was before. So it's much faster now to actually find the frequency. The other thing you can do is if you dial these pages, then you can select a specific one. Oops, so I'm going to go to nearest, which will have Palo Alto in here. And then I can actually go... let's see if this works. Okay, so now we're on the waypoint page. Let me make sure that these are called pages. I think they call them page groups here, but they're not always right about that. To follow up. Okay, so at any rate, I'm in this waypoint now. I can flip between to the frequencies. They only list Palo Alto's tower frequency. So I'll show you how to do this. But what we really want to do is tune ground for our ground call. Okay, so 125.0. And now we put that into the active. And, oops, not enter. Use the cursor. Select this, and if we hit active, it'll put it into our standby frequency. So now when we want to go from the top one is what we're currently talking on, they'll eventually tell us to switch over to tower. We can go like that to switch over. So okay, so that's kind of a nice thing to do, especially if you're flying in an area you're less familiar with. Of course, in real flying, you would have planned out what your airports are available. You would know those frequencies and have them sort of readily accessible, so you aren't digging through pages like this. But if you're kind of casually flying around in the sim and you just want to go to a near airport, there's a couple of features that come with the sim, like the ATC scroll and stuff like that. But you can also go into your GPS, select the nearest. For instance, let's go look at San Jose. So if we do enter on this, maybe we page over to the frequencies, and you can see all of these. And unfortunately, this is not super well set up, and my memory of the real GPS interface is a little bit easier to use. For instance, their ATIS information is, I think, well, actually I could just look it up. It's like 126 or something like that. And so, oh, that's all right. But you could do the same sort of trick. So if you hit enter on this thing, it'll put it in your standby, and then you could use it. So, all right, let us get out of this, back to nav. This is useful. And we will go like this, and we can zoom in just a little bit. Let's see what they have a little bit of the airport diagram. Cool. Okay. If there's anything else I want to do here. All right. Little sidebar while we're sitting here idling. Oh, and because I jumped into setting the frequencies. Okay, so later on in my checklist is typically where I set the frequencies, because we do want to set our mixture for taxi. So the way that we do this following the POH is we bring up the throttle to 1,200. So you can see I'm bringing the throttle in a little bit, 1,200. And we'll follow the POH procedure. The reality is that it may not work the same in the sim, so I'll tell you what we're hoping to see, and then we'll just kind of go from there. So 1,200, and then I'm going to slowly bring the mixture back, this red knob here, until I get peak RPM. And that peak RPM is where I want to set my mixture for taxi. So I'm kind of bringing it back. You can see the RPMs rising a little bit, which is actually pretty impressive, to be honest. I didn't think it would be simulated this well. Okay. Looks like it's still going up. Now it's coming back down again. Okay, so in the sim, the peak RPM was like maybe right about here. This is a really good procedure to do in whatever airplane you're going to fly. Once you've done it in that airplane, you can use the same general spacing of what it is. So one trick you might see people do is they'll kind of take their thumb and maybe they'll lie it lengthwise across here if that's the right spacing, or they might do the long one. Since I'm using my honeycomb throttle quadrant, I sort of have the spacing set. It's about the width of my finger here, so I'll use that. And then of course we want to bring this back to 1,000. Okay, great. And now we are coming in to do our we're going to ask to taxi. So we'll talk to Tower and say we'd like to taxi. Again, so it's the same setup every time. Who we are, where we are, what we'd like. So right now we are on the, can't quite see it from there. Let's see if I can get a better view. So we're on Romeo taxiway. That's what that R means. And so we're going to taxi along Romeo. We have information Bravo, and we'd like to do a left Dumbarton departure. So left Dumbarton departure. Pull back over to the Mac. So again, same thing. We are currently on Romeo, and so we want to kind of go like that. And a left Dumbarton departure means we want to depart the airport, continue flying north until we get to the Dumbarton Bridge, which is this bridge right here. And so essentially we're going to fly and continue climbing, and then we'll cross the 101 and then continue on our way. Okay. I'm thinking for a fundamentals of flight flight, this may be a little bit much information, so I will start to just do more of these things. If you have a question as we're going along, feel free to post it in the chat. But otherwise, I'll kind of simulate what the radio calls would probably sound like. So we'd hop on and say something like Cessna. What Cessna are we in right now? Oh, didn't use my my preferred call sign. So every airplane will have somewhere in there the call sign for it. So this is Alpha Sierra X-Ray Golf Sierra. That's the default one that they use for Microsoft Flight Sim planes. Typically, I change it to Alpha Lima Tango India Sierra because I think it's kind of fun. But at any rate, we'd call them up and we'll say something like Palo Alto ground, so the ground frequency that controls the movement. Palo Alto ground, Cessna Alpha Lima Tango India Sierra on Romeo with Bravo for left Dumbarton departure. So I've told them who I am, where I am, the information I have, who I am, where I am, and what I want. And I also need to let them know that I have the information, the latest weather. And so then they'd say something like Alpha Lima Tango India Sierra. Oh, I was on the wrong thing for this last bit. That's okay. What I was showing on the plane, sorry about that, is under the cowling here, it'll often have the N number for the plane. So I noticed that this wasn't the one I usually set when I'm flying, which is Alpha Lima Tango India Sierra. I'll use that for today because I think it's kind of fun, but if you do choose a custom call sign, it'll show up there. Okay, so they're going to say something like Alpha Lima Tango India Sierra, taxi to runway 31. You'll see that I'm writing down what they're saying. Runway 31 via Romeo Yankee terminal side. They usually say it's sort of a historic thing we can talk about, but they'll say Romeo Yankee terminal side, Yankee 1, Zulu. Advise run up complete. And so my response then would be runway 31 via Romeo, Yankee terminal side, Yankee 1, Zulu, and then my call sign, so Cessna Alpha Lima Tango India Sierra. You can say back to them, advise run up complete when you're first getting started. Reading back all of what they said to you is just fine. Over time, you'll learn what's required responses and what's just sort of their advisory pieces of information. So they do expect you to advise when you're run up complete, but you don't necessarily need to say that back, and it keeps the radio frequency less congested. All right, let's go back here. So now we're taxiing. Oh, the other thing that you can and should do then is, so we have our taxi instructions. We can go back to the map and kind of draw what that is. So they said to take Romeo, Yankee terminal side, and then to the run-up area. So we'll stop over here for a minute, and then we'll continue taxiing Yankee, Yankee 1, and then Zulu takes us to 3-1. You may have noticed in our original Bravo, they gave us the expected runway 13. When it's bad weather in the bay, often it's the opposite runway from the one we're going to take off from. Because it's good weather now in our game, we're just going to use the standard runway, which is 3-1. But 13 is the one they actually had told us, so that we would get a whole different set of instructions for that. All right, so let's start taxiing here. I won't show my iPad at the same time as the sim, but you'll notice that on here I actually have an indication of where I am on the airport. So I have this in my lap and I can kind of see where I need to turn to make sure I'm not getting lost. But I will flip back here and let's start taxiing. So first of all, I want to make sure there's no airplanes around before I start pulling into someone. Okay. And take the parking brake off. Bring the power down, and then I'll just sort of bring up some throttle just to get the plane rolling. Don't want to add more throttle than is needed. Start pulling out really quick. Okay, there we go. This guy doesn't really exist, so sorry, bud. Oops. Or maybe he does. There we go. Okay, I was gonna say, I think I can just pass through him. Looking around. Okay, so I want to catch up with the yellow line here. Not using any brake because I have power in. As soon as I want to brake, then I need to bring the power back first. Remember, we don't want to taxi while also braking. Very, very touchy today. Okay, here we go. Trying to get myself back aligned. Good, good. Okay, and we want to be going about walking speed, so I'm going a little faster, so I'm going to bring the power back. Okay, oops. And I'm going to turn the lights on. This is the thing that we talked about for pre-taxi. I'm bringing power down a little bit as I come into this corner because it's kind of a sharp corner. Don't want to be just tailing around. Oops, I applied a little bit of brakes, which stopped me immediately. Call it a sim artifact. As we're taxiing here, I'm doing a couple of things. One is I'm always looking at intersections to make sure there's not planes that we're going to be turning into. I'm also checking my instruments to make sure that everything looks like it's behaving correctly. We'll talk more about that later, but one good one to just check out is the magnetic compass up front. Just right on the front of the cowling up here. Because you can kind of see it should match the headings of the directions of the airport that you know and expect. So on this taxiway, about 310 reading on the compass is about correct. Okay. Again, staying on the yellow line. It's pretty interesting in the sim, some of the differences that pop up. One is that the plane itself is pretty heavy, right? But in the sim, it responds as though it has no weight. Like it has momentum that it definitely carries through, but like the brakes are like instantaneous and the throttle changes are felt right away and stuff like that. That's not really how it works. All right, since there's no other airplanes here, we're gonna pull into our first T-bar. Again, we gotta remember that we have, so I'm using a little bit of toe braking, a little bit of differential braking to kind of edge myself in here. And we also have to remember that we do have long wings, so we gotta be looking out our side to make sure we're not gonna hit anything. Okay, so that's pretty good alignment for it. Bring this back, and then I'm going to put the parking brake on. A lot of pilots are in the habit of not using the parking brake at all, especially on trainer planes, because they're often kind of weak. I am one of those pilots too. I only use the parking brake in sim, but in real flying, I'm always holding the toe brakes. Just because I have had enough parking brakes that can just be overpowered during the run-up. So let me bring this back up. Every time we stop, we want to bring the RPM to 1,000. So bringing the throttle in a little bit more. All right. Go through a run-up checklist. Parking brake set, passenger seatbelts upright, or seat backs upright, seatbelts are secure, cabin doors closed and locked. They look good. I might check the back seam just to make sure that there's nothing funky going on. And then you can also just kind of push on the doors just to make sure that they don't pop open. If a door ever does come open in flight, it's not the end of the world. The air movement of the air across the fuselage will keep it closed, so it's actually kind of a non-event. It just feels like an event because it's kind of loud, but it's actually not that big deal. That said, you still don't want your cabin doors opening. Next thing I'm checking is my flight controls, so I'm going to box my controls like this all the way through the full range of motion, make sure I'm not hitting anything, which I actually do hit my honeycomb quadrant. Is kind of funny how that works. And then the next thing I'm doing is I'm going to rotate to the left, and I expect to see the aileron on the left side rise, and sure enough, it is rising. Good. And now I will go to the right. Let me drop this down so you can actually see. So now I'm flipping over to the right, and I expect to see that aileron go up. The thumb on top, when you're holding your yoke, should point at the aileron that's rising. Okay, so that's rising, so that's good. Okay, I'll reset my camera here. Flight instruments check and set. Everything looks good. We got our altimeter reading because we're using fake weather. Our altimeter is 92.92, which is what's set in here. The actual one that we got was like 92, 29.87, which would be a little bit lower. So if we set that, we expect to see the altimeter to match the altitude of the airport, and this is within a good margin on that. So we're about at sea level, so we expect to be about at sea level. We might look at our attitude indicator, make sure that the orange lines up. If you needed to change that, you could raise or lower it a little bit. In the sim, it pretty much always looks good. In a real plane, you might need to actually adjust that. Just depends on the height of the person using the plane previously. The other instruments look good. Fuel quantity check. So that was also part of our pre-flight. Mixture rich. So let me bring the camera back here. So I'm bringing in the mixture. We'll do our run up. So we bring in the throttle to 1800. Okay, good. And then we'll check on over here. We're going to check our left magneto, or sorry, our right magneto. We expect to drop less than 150, but mostly we want the two to be very similar, within 50 RPM of each other. So we go that, and we got a drop of 110 maybe. Okay, good. Bring that back up. And then on the left magneto, drop of, it actually seemed like more of a drop than I'd expect. Let's see. I'm gonna zoom in a little bit here. Okay, so 1800. On our right magneto, we get a drop of, okay, so 1660, just about like 120 or so. Okay, no, it was the same drop. I just couldn't see it very well. I was gonna say I'd be surprised if the magnetos in the sim weren't working. Okay, bring that back. And then we want to check our vacuum gauge. So come over here, we'll look and see the vacuum's in the green. That's good. Amps are charging. That's good. Fuel selector, double check that it's both. Good. Okay. Engine instruments, everything else looks good. Fuel flow is reasonable. Temperature, oil pressure, good, good, good. All right, and then reset this camera, and now I'll bring the throttle all the way back to idle. I want to make sure that it idles at a reasonable speed. Okay, seems to work just fine. Bring that back up to 1,000 now that we're done with the run-up. Okay. All right, next thing is the heading indicator. So I want to make sure that the heading indicator I see here matches the heading indicator here. So we are, and one thing to notice is these sort of read backwards. This magnetic compass is actually as though you're seeing it through to the back side of the compass. So just sort of a bit of a brain warp thing. But so you notice that it's just to the right of west here is actually 2-4 is off to the right. But on this one, 2-4 is off to the left. It's because you're sort of seeing the back side of this card as opposed to seeing it from the front on this one. So it takes a little bit of getting used to, but you'll get it. So we are at about 255 compass heading, and if we zoom in here, let's see if I can actually zoom in. So we're at about 250 to 55-ish, a little bit over 257. 250, 260. Okay, so this is saying about 260. I'm gonna bet that if we move our camera over, yeah, there you go. So if we were looking straight on, it would be just beyond 260. And sure enough, this one is just beyond, see, this is just before 260. Okay, so we can actually adjust this then to make it match. So it should be that it's these two things match. So that's just beyond 260. Over time, because this is a gyroscopic instrument, this will precess. And so throughout our flight, we'll have to periodically check and make sure these two stay aligned. In the simulated planes, it's like having a really, really good gyroscope, so it very infrequently precesses all that much. But in a real plane, you may run into that more frequently, especially older planes. All right, the last thing I'm going to do here is set my heading bug to my runway heading. So I'm going to dial this back to 310. And we do that for two big reasons. One is when we actually line up to take off, we can confirm that we're lined up with this. The other piece is that when we're flying out, then we want to make sure that we're maintaining runway heading or staying aligned with the center line if we're correcting for wind. So we'll talk more about that later, but it's a good habit to get into. All right, flip this to GPS, and a typical trainer plane that's almost always already on GPS because it just stays from the previous person using it. I'm going to move something here. So I'm gonna make a note for follow-up afterwards. My current checklist, I'm using my custom checklist, not the one from the POH. So it's pulls from the POH, but then the flow of certain things has changed, so it's a little more logical. Otherwise, the POH sometimes have you moving all over the panel and doing kind of a weird order of things. But the POH has you, I'm sorry, the checklist I have now has this test happen way earlier. Anyway, I'm going to test the warning lights here, make sure they all show up. So I hold it up on test. Good. Everything illuminates. Okay, good. And now we'll test the autopilot. So the way that we do this, engage the autopilot. And we want to make sure that the autopilot is working as we expect. So if I turn it working as we expect and that we can overpower it. So if I turn on heading mode, we expect the plane to want to turn to this little bug. So we expect to see that the yoke will start to rotate to the right. Let's see what happens. Okay, good. So it's working as we expect it to. And I'll go all the way there trying to do that. And then if I turn it back on my own yoke control, I should be able to overpower it. Okay, good. So I can overpower it. Of course, in the sim it's a little easier. And that also disengaged the autopilot here, which is potentially what we expect to happen. Okay, interesting. The other thing that I want to check is that I can disengage it using the normal methods. So on the yoke itself, there's a disengage button. Let me see if I can get over. So this is one to check. Okay, good. So as soon as I hit that, it disengaged the autopilot. That's good. You don't necessarily need to have it in heading mode the whole time if you want it to just come back to... oops. Interesting. Okay, now I'm trying to use my yoke and I can't. I actually can't remember if Microsoft Flight Sim lets you overpower it all the time, so you may really need to disengage autopilot if something comes up. But at any rate, you can also hit the autopilot button, that'll disengage it. And I don't know if they have, there's another button on here that you can check if they have it, and I don't know that they do. And of course, if you ever had a runaway autopilot and you really needed to disengage, you can pull the autopilot circuit breaker, which is supposed to be down here. Maybe they don't have it modeled. Ah, there it is, autopilot. So you could pull that circuit breaker out. Sometimes it has a little ring around it, so it's easier to pull. Just in case of emergency. But these other two are reasonable solutions instead. So. Okay, I digress. And it is an hour into our flight, and we haven't yet taken off. Okay. Manual electric trim. Oops. So the other thing I'm going to check is, can I adjust the trim with my electric on my yoke? So these little two buttons, you got to use them both at the same time. My throttle quadrant has one, so I can do that. And then I set this trim back to takeoff. So I want this white line to be aligned with that triangle. Takeoff brief. If we find our airspeed does not come alive, if we aren't at the airspeed we expect by the time we're halfway down the runway, we'll talk more about this when we get to kind of the emergency procedures. But if we haven't gained the speed we expect, we'll bring the throttle to idle, apply full brakes, taxi off the runway, and figure out what's going on. If we have already taken off, or if we don't have enough runway remaining and we need to take off, we will plan to land straight ahead. There's a nice field out in front, and the focus in that kind of scenario is to pitch for 65 knots and just fly the airplane to the ground. So just a normal landing. And then if we are at pattern altitude of 1,000 feet, then we have enough altitude, we can turn back around and try and land on a reasonable surface of the airport. So that's our board brief if we need it. For takeoff, our plan is to do a left Dumbarton departure, so we'll fly up to the bridge and take a left and continue to climb. There's a Bravo shelf, so we'll climb to 2,700 at first. Once we get out in the practice area, we'll be able to go between 2,500 and 3,500, just for some practice. Set my wing flaps to 10, that's this guy. And we are ready for a normal takeoff. So I'll do the takeoff for our flight today. In future flights, then that'll be the student gets to do. So I'll say Palo Alto ground, Cessna Alpha Lima Tango India Sierra, run up complete. They'll say something like Alpha Lima Tango India Sierra, taxi up to hold short Yankee 1, contact tower. So we'll say taxi up to hold short Yankee 1, contact tower. And then we will do that in that order. I'm actually going to leave my flaps up because I like to be able to see underneath. Yeah, okay, so let's do this. Checking to make sure there's no one over on my left. Taxiing through, oops. I love these camera controls. Make sure this. Sorry, got going a little fast. It's not good. You really want to be about a running, or I'm sorry, a walking pace. So I'm actually gonna, my throttle's all the way back, but the plane is not slowing down. All right, so come up to about here, just short of Yankee 1, and we'll say Palo Alto, and then we switch over frequencies, so we can do that here. Now we're on the tower frequency, Palo Alto Tower, Alpha Lima Tango India Sierra, short of Yankee 1, ready for departure. And they'll say Alpha Lima Tango India Sierra. My alignment on the yellow line is not great. Well, that's right. We'll work on that. And they'll say something like Alpha Lima Tango India Sierra, clear for takeoff runway 31, and then we respond clear for takeoff 31. Okay. They might also give us a bunch of other kinds of instructions. Just depends on who else is around and what's going on. But we'll talk about those more next lesson, actually, which is about working on the ground operations of the airport. Okay, so I've been cleared to cross that movement area. That's sort of a thing kind of unique to Palo Alto among other airports. So now I've been cleared already to take off 3-1, so I can cross these hold bars. Otherwise, the double hold bar here is always something you want to stop on. And if you're ever not sure, it's always better to just stop and clarify with the tower. They'd much rather you ask if you're not sure than to just violate, because that gets you and them in some trouble. It's just not worth the hassle. As soon as we cross the hold bar, we want to do lights, camera, action. So actually, we don't have this on. Typically, this would already be on. So we need to put our transponder. Oops, this is not good. We want to have this all done beforehand. So I'm actually going to pause here. We should have done lights, camera, action before we crossed the threshold. And so we want to make sure we're in altitude mode, 1200. First of all, so lights, so turn on all of our lights. Camera, can ATC see us? So this is the ADS-B transponder, and so this is how they'll see us. And then action, and for action I want to bring my flaps to 10, mixture full rich, my pitch, so that the flow is sort of like this. So you go pitch trim for takeoff, so the triangle's on that little white thing, mixture full rich, flaps to 10, and then we'll bring the throttle up to go. So, all right. And I'm gonna switch to my other view here. So now we are good to go. And I'm bringing in my throttle over the course of about 4 seconds. So you don't wanna just jam it forward. You wanna give it a little bit of time. Just a little bit though. And maybe 3 seconds is probably fine. All right, airspeed is alive, looking good. Staying aligned with the center line, waiting for 55 before I rotate. Okay, good, rotating at 55. Pitch up, and I'm pitching up to a known attitude. So this is a lot of what we're going to talk about today, but there's a picture I have in my head of what it should look like, and that's what I'm pitching to. My airspeed's a little low. I want to be climbing out at 76. So I'm going to pitch down just a bit. Okay, I've got a little bit of right rudder in to correct for left turning tendencies. We'll get to see a little bit of that today too. Okay, there's 400 feet. So we have a positive rate of climb, and we're above 200 feet, so we can do our cleanup. So I brought the flaps up, went from 10 to 10 degrees of flaps to 0 flaps. And then we are climbing out at VY, which is 76. The other thing that I'm doing, because we're at Palo Alto, is I've turned about 10 degrees to the right, so you'll notice that my heading indicator is no longer lined up with the runway heading. That's intentional. So I'm actually going to put the nose down just so you can kind of see it. I'm actually going to this thing off in the distance as a good reference point of where you should be going. So, sorry about that. All right. Attitude seems okay. For a left Dumbarton departure, we're going to turn left as we come to the Dumbarton Bridge. Every time we turn, we want to look under our wing, and then we can kind of go left. We initiate the turn. Well, we'll talk more about turns in a second. We're going to do a whole lesson on them. So I'm continuing to climb. Very good. Just looking down at my iPad. All right, so let's start off here with a heading of. I have to sync this. Okay. That might start to get annoying. Okay, so we'll start off with a heading of 210. Try and maintain that heading. Now I'm climbing to 2,700. Climbing at 90 knots is what I'm aiming for. It's about what I've got. I'll talk about all of what I'm doing and what I'm looking for. The other part of my cleanup, I'm going to turn off my landing light now that we're kind of on our way out. We don't need to be using the full light. We'll leave the other ones all on. Looking good. Now, one of the things I mentioned yesterday, a saying that I really like, the two most important things in aviation are the next two things. So we want to always be thinking about what the next two things we're going to do are. So the next two things that I need to do is be anticipating my level off. I want to level off 50 feet below, actually more like 100. We can talk about why. Below 2,700, so I make sure I hit this target. And then I want to bring my power to 2,400. We're going to use 2,400 most of the day here. So let's get ourselves leveled off. My heading's okay, but I want it to be precise, so I'm going to come a little bit left. Okay, let's see. Kind of climbing here. Good. All right, now we're getting to straight and level flight, and we have a couple of important things to talk about. So let's use. Let's get up to our correct altitude. Should be as precise as we can be when we're flying these sorts of things. Especially because we want to be able to one day fly around like SFO's airspace, and they're going to ask us to hold a specific altitude and expect that we really, really hold to it. All right, so let's take a pause here and talk a little bit about. So I'm going to use pause break throughout the lesson today because it's one of the advantages of the sim, and so we might as well take advantage of it. Okay, so let me step back over to the Mac and we'll talk a little bit about straight and level flight. Okay, straight and level flight. Hopefully the audio sounds okay. One thing to know early on is the process for scanning for traffic. So what the FAA recommends, and what I would also recommend, is you want to use the best of your human vision and understand how the vision works. Specifically, we are really good at detecting motion. We're not so great at picking out just like kind of a specific point in the sky. So if there was another airplane flying around, you're a lot more likely to detect it by seeing that there's some sort of motion in your field of vision. In order to do that, though, you can't have your eyes be moving. And so they recommend picking about a 10-degree quadrant to the sky, and you want to be looking at just that quadrant for just a second to try and detect any motion, and then move to the next 10-degree quadrant of the sky, and the next 10-degree quadrant. And so you're kind of doing this 10 degrees quadrant of scanning all the way around, and always looking for a little bit of movement. This is one of the things that I am will be a very big frustration for me in the sim, because if we were actually out flying in a real plane, you would see that I'm constantly doing this sort of 10-degree scan looking for traffic, especially because the Bay Area is so busy. But in the sim, we just don't have, like, for me to be doing that, turning the camera all the time. You can't really glance at the instruments. It just doesn't quite work the same way. But let me at least flip back. I'll flip back quick and show you what I mean by a 10-degree scan. So go like this. We might do something like, look at, this 10 degrees here, and then like maybe this 10 degrees, this 10 degrees, this 10 degrees, this 10 degrees, that 10 degrees, that 10 degrees. And every time we're looking to see, is there any motion, are there any planes in that area? So, okay, so that's something, a part of getting, a part of building proficiency with flying in general is this ability to scan and to be consistently looking for traffic around you. It's a big thing when you go up on a demo flight. You'll see your instructor is doing this all the time, because like you as the student are really focused on trying to fly the plane early on and also building the muscle of how to scan for traffic while doing it at the same time. But your instructor is like, like a hawk looking for things. Okay, the next one is visual horizon to maintain direction and pitch attitude. So an important piece of visual flight rules flying, when you're flying with a reference to the horizon, is you aren't flying by looking at the instrument panel. You're actually flying by looking at the horizon and what you see like out here. So let me go back to the Mac real quick and talk a little bit about what I mean by this. So one thing is you want to do periodic cross checks of your instruments, but you're really aiming for about 90% of your time to be looking outside of the flight deck, and then about 10% of the time that you're looking inside of the flight deck. So this is one of my biggest concerns with folks who come from a flight sim background, is in the flight sim, it's very rewarding to look at the instruments because they're all so precise and you can kind of fly based on those. But the reality is, to fly visually, you don't really need the instruments as your primary way of flying. You're really flying based on the attitude that you're seeing relative to the horizon. So for instance, you might be looking out. I'm going to flip back to the sim real quick. And so like I'm looking at my left window now, and I can see where my wingtip is relative to the horizon, and I can see my attitude, my pitch up and down based on that. And then I can cross-check on my instruments that 10% of the time, just briefly, to make sure that everything's what I'm expecting. So for instance, like this. But then I might cross-check my instrument, my attitude indicator, and sure enough, my wings are level here. This shows that I'm in a slight turn, so kind of look at that. But these should also be level. But really, I'm using that outside reference in order to maintain my direction and pitch attitude. The other piece of that then is actually picking a point on the horizon to be your heading. So specifically, if we're going to go, like I said, to use a heading of 210, so that's this, where I have it bugged up in the direction we're currently flying. But the more useful thing would be to say, I'm going to fly to that open patch of dirt out there. Or really what we're going to do most of today is we're going to say, we're going to fly towards like this mountain peak, and then we're going to fly back towards San Francisco or something like that. So we'll pick very specific references, as specific as we can, on the horizon that we use. And what that looks like in practice is this. So what I'm doing is I'm picking a natural horizon reference point that I'm using to, one, keep my heading set how I want it to be, but then also for the straight and level picture. So you hear sometimes people say if you put up kind of 4 fingers and stack them, that's how far your cowling should be from the horizon. It kind of depends on your height and the way you have your seat set up, but in general, I'm going to flip back to the game here. Oh, let me see if there's anything else I want to talk about before I'll just drop this. Okay, we'll talk about use of trim in a second. Okay. So if we go back here, this is what I was talking about with the importance of the seat height. So when I'm down like this, I can see out the window, but really I prefer to be flying like this because I have this picture that I'm forming of what the horizon should look like. We're looking at the mountains. Let me get to a slightly better horizon image here. So I'm gonna actually turn around. So when we're first getting started, well, we're going to talk about all these things in a second, so I won't belabor it too much. I was going to start talking about how to do a turn, but that's sort of the whole topic for the day. So what I want to do is get back to, I just want to show kind of what I mean by the picture of what the horizon should look like. Sorry about that, grab my iPad. Flight deck organization. Okay, great. So we're at 2,400 RPM, straight and level flight. I like this picture. And so this is what I would ask a student to memorize. So it's the sort of the distance from the top of the cowling up to the top of the horizon out here. That should be pretty much constant whenever you're in straight level flight. So when we talk about attitude flying, what we mean is that you are looking outside the plane to see what the picture of the horizon looks like. And then you're also looking at your wingtips to see if you're level with the horizon. So, oops, not that way, but this way. Okay, so that looks level, and I wish I could see a little bit low. Okay, we'll go like that. Okay, so it seems like my left wing might be a little bit lower than my right wing, when really they should be level. So let me unpause this real quick. Roll wings level a little bit. Okay, and so there we go. There's my left wing, my right wing. Okay, good. Now we seem like we're level. So let's pause and take a quick look. Okay, good. So we're level to the horizon. Sure enough, if we use our quick confirmation inside the... Oops, did I mess this up? I did. Quick confirmation inside. So this is also showing wings level. This is slightly above the horizon. And sure enough, if we look at our vertical speed, it looks like we're climbing. And so let me go back here and make sure that... What's going on with that? So my RPM setting was a little low. I should be at 2,400. There we go. Trying to get this all set and trying to hold 2,700. All right, so I'm going to turn back. That's what that kind of sight picture means. Okay. So straight and level flight. At this point, then it would be a little bit of the student practicing just flying straight and level, kind of seeing what all that takes. We can talk about turns next. So, well, actually, let's talk about climb to descent. So I'm going to turn the airplane around. I'm trying to think, if I was out with a student on this flight, I would want them to be on the controls most of the time. And so I think I would want to talk about turns earlier. I'm going to do that, actually. Okay, so we will talk about turns next. So for a just a standard turn, just for just a normal kind of turn, what we're trying to do is maintain the same altitude while turning back to a specific heading. It may be a heading that we have set based on like a compass heading, or it may be something off in the distance. So I'm actually going to turn back to San Francisco. And you'll notice that I'm using about 15 degrees. You know what, we can do 20-degree banks for this. But really, we don't want to be going beyond 30-degree banks at this point in our flying, just because we're still getting used to all these things. So I'm using about a 20-degree bank. Again, most of the time, you should be looking out at the horizon here. Okay, so I'm going to head back towards Crystal Springs. That's this reservoir here. And that's where I want to have my nose pointing. So I'm pointing a little bit left, so I'm going to come back here. Okay, good. Now, good practice is to bug this up so that you have a secondary reference, and I would recommend that as well. So I'm going to actually dial this in. Good. So now one of the things that I'm doing that we should talk a little bit about on straight and level flight is trimming. So the airplane is designed to fly itself at a specific altitude when you have, will maintain its own straight and level flight if you've properly trimmed. So the trim is this thing down here. And essentially what I'm doing is, while I'm flying straight and level, I'm just trimming so that I don't need to hold, how do I say this? I set the picture that I want to see. Oh, I didn't move myself up. So I set the picture that I'm expecting to see. So here's my picture of what the world should look like. And again, if I look, I want to look and make sure my wings are level. And okay, we're looking good. And that's the picture that I'm expecting to see forward. And so I'm holding that picture on the controls, but I should be able to trim out control pressure. And what that means is that I shouldn't need to constantly be pushing on the controls to maintain that picture. Instead, I will use the trim, this little wheel thing, and kind of trim it out so that I don't need to. I wish I could show just a little bit lower. Okay, so there you go. So you can see that I'm just slightly adjusting the trim here to keep that picture the same. Sorry, this is where like, yeah. Okay, I'm gonna use this consistent picture so that we have it consistent. And I'll just mention when I'm using the trim. So I'm just tapping on the trim a little bit. Now I've stopped heading towards Crystal Springs. I really should keep going back that way. So I'm gonna turn towards Crystal Springs here. I want 2,700. We'll just keep using that for our setting. Okay, good. So again, I'm looking for the picture that I'm seeing ahead of me and confirming on my instruments. So mostly I'm looking, and I might look down out the windows, make sure that my wings are good. The whole time scanning for traffic, so I'm always doing the 10-degree sort of thing. And then I check my instruments. And so what are my instruments saying? I have no vertical speed, which is great. It's supposed to be level flight. About 110 knots, that makes sense. 2,400 RPM, everything's looking good. Okay, so I just touched the trim just a little bit. This is one of those, the sim being particularly touchy. Okay, so let's talk about turning. Pause on that one. So head back to the Mac. For turns, the first thing you want to do is check for traffic. So in a high wing plane, we're going to lift our wing slightly because otherwise our wing actually blocks where traffic might be. We need to correct for adverse yaw, which I'll talk about in a little bit. What's a good way to talk about adverse yaw? So okay, there's a picture that I really like that I think I already have actually. Let's see if it's in here. Yeah, well, okay, so adverse yaw, this is the definition of it, which is sort of useful in one way, but not useful in another way. Let me quickly change this and then make a note. Okay. So adverse yaw, sorry, let me say this differently. When the airplane is, oh, that's what I forgot to put in here. Okay, this needs to have a 4 forces. Okay, so let me quickly pull up a picture that's going to be kind of critical to understanding what all's going on. And this is the 4 forces of flight. So let's see if AOPA has a good. AOPA is a great resource for a lot of good aviation information. So if you're ever looking for just a starting point, they often have some of the best content, but they also have pretty good presentation of it. Okay, so this will work okay. Let me do like this. Okay, so this is from AOPA. And I will get a better picture of this later to put into the syllabus, but we can at least talk about it kind of at a high level. So there are four forces that act on an airplane when it's flying. There's thrust, which is generated by the propeller. This is the force pushing you forward. Drag, which is a force that pulls you backwards. Lift, which is created by the wings that goes up. And weight, that always goes down towards gravity. The reason that's important is that when you're climbing, the weight is still going to go directly down, even though, do this, grab this other one. Again, this is, what is this from? Pilot's Handbook of Aeronautical Knowledge, it looks like, which is great. That's where I would have got it from. So we'll look at this one too. So when you're in a climb, weight still always pulls down, which means that you need additional thrust to actually climb to counteract this bit. They call it the rearward component of weight. And so you'll see when we go into a climb, we actually add more power. Sorry, that's sort of a deviation. The important piece of the four forces that I want to point out for a turn is that the force of drag is a byproduct of the creation of lift. So when lift is created, drag is also created. So because there's lift being generated, then there's a certain amount of drag. When you're turning the airplane, essentially what you're doing is you're, let me see if I can find a photo here. This would be a really good one to, I know exactly what image I want, which is kind of the extra frustrating part. So sorry for the delay. Yeah, okay, but this will pop it up. So I'm looking in the PHAC chapter 6. Yep, great. Okay, that is exactly the picture I wanted. I thought I had this. Let me just see if I can find. Nope. Okay, well, I'll pull that in later. So this is the PHAC's depiction of adverse yaw, and I think it's a really, really useful summary of what's going on. So when you're turning, you're deflecting your aileron up or down. So let's say that you turn your throttle or your control yoke to the left, which is what this picture is depicting. That's going to cause your left aileron to rise up. When the left aileron rises up, it produces less lift, and the right aileron then is going down. So left aileron goes up, right aileron goes down. Because this goes down, it creates more lift, and when it creates more lift, it creates more drag. And so that causes the airplane's nose to rotate to the right. What that looks like in practice, actually, we can see in the sim. Let me see if there's anything else on here I want to point out before we jump into the sim. Use of rudder, initiate the turn, cancels out adverse yaw. Okay, yeah. So adverse yaw is a byproduct of using the ailerons to create lift. Using the ailerons at different angles to create lift. So the down aileron creates more lift, creates more drag, which yaws the nose away from the turn. And so we fix that by using the rudder, and I'll show you what all this looks like in the sim and what other things we're looking at. The last piece we'll talk about is the load factor. This is why doing the ground session beforehand may be useful. Let me think if I want to talk about this right now. Yeah, we could talk about the aft pressure to maintain attitude, or altitude. So to do add picture. So when we're turning the airplane, there's that lift vector that gets created, that's the lift created by the wings, is no longer pointing directly up and down. instead it's pointing at some angle to the side. So let me just grab another one just to show kind of what I'm talking about. So this is just a random aircraft photo from the PHAC. So this airplane is in a turn, and so the lift vector is actually to the side. That means that, oops, this guy. That means that, oops, let's get a better color than black. What about pink? Okay, so we have some lift vector that's going this way being created by the wings. But the weight is still directly downwards. And so to counteract this weight, sorry, this is a poor way to explain it, and I know I have a better item for this. Let me see if I can just find it. Component. Maybe lift. Ah, here's one. There's the one I was looking for. Lift, thrust, drag, weight. Okay. Well, I did find the one piece I wanted. Okay. Well, I'm sorry that this is a little clunky here. So let me just explain this as best I can using some quick resources. My dog's running around, and our floor is a little slippery in some points, and he gets a little nervous about it. Okay, so I'll do the best I can to explain this just with a couple of quick images, and then apologies for the missing images here. This would have been useful to have. Okay, so I'm just trying to find a, you know what, that's okay, I can just draw it real quick. So let's grab that picture that we were looking at before. Like that. Okay, so this is an airplane in a turn. I'm going to draw next to it just an airplane not in a turn for reference. So say that we go something like this. And so if we have an airplane that's just in level flight, so there's our ISIL airplane. Okay. Then there's some amount of force that's going to be, can I just draw like this? Highlight selection. So this is the force of lift coming up off of the plane like that, and that's going to equal the force of gravity going down, right? In a turn, we have that exact same force of gravity going down, but some of our lift is being redirected in the horizontal axis. So that's how we're actually going to be able to turn. And so although our lift vector is the same distance as it originally was, not all of it is going to counteract the gravity vector. And so, you know, we have like let's say that this is, let's see if we can make this a little longer. Look at that. And so, you know, our horizontal component of lift, this piece that goes off to the horizon, is now in turning, we've now redirected some of our lift into the horizontal plane and the vertical plane. And so there's some amount of this that needs to be made up in this vertical plane, right? There's like some missing here that needs to be counteracted for gravity. To account for that, we actually need to have a greater lift vector than we would have needed for just straight and level flight. And to get more lift, then we pull back on the yoke a little bit. So what this means when we're doing our turn is we're going to roll into it, and then we're going to apply just a little bit of back pressure. And notice that I don't say pull back. It's really just pressure. You're just kind of putting a little bit of pressure on the yoke. And that's going to keep the plane flying at the same altitude. I will show what that means real quick in the sim. I think that'll be a helpful sort of illustration. All right, so back in the flight sim, flip over here. So let's first look at adverse yaw and see what I mean. So what I want you to watch, I'm going to do a really aggressive sort of turn. We'll look at the plane from the outside. I didn't know that it wouldn't reset. Okay, that is okay. So, and I want you to watch what happens when I turn and how the nose, so I'm going to turn to the right, and you're going to see the nose swing to the left. That's the adverse yaw. So I won't use any rudder to do anything about it. So we'll unpause our flight here. If I turn to the right, let me see if I can do this again, get a little better picture. So turn to the right. You can kind of see the nose is swinging around. Let's do it differently. So right now I'm looking directly at Crystal Springs. If I roll to the right, the nose sort of swings through the horizon. You see that? So it's doing this sort of like back and forth thing. Not the best adverse yaw demonstration. That's okay. So we're going to hold 2,500. So the other thing to look for, at least, that may be more clear in the sim, this ball shows us if that, if the plane is flying coordinated. So if it's carving through the turn with gravity kind of pushing straight down, which is what it should be. So if I just bank to the right, you'll see that this ball swings off to the right. So it's gonna, as I turn to the right without correct rudder use, then the ball goes off to the right. And then after we establish in the turn, then the ball kind of comes back to center, because when we're in the turn, I actually don't have any, I'm not using the ailerons at all for deflecting. So when I get out of the turn, I might, or to initiate the turn, I use the ailerons, but once I'm in the bank I want, then I don't need it anymore. Okay, so to initiate and then let it go, right? So setting the 10 angle that I want. So every time if I roll to the right, I need to also at the same time put in some right rudder to keep the plane coordinated. So the saying you'll hear is step on the ball. So the ball is swinging to the right, so I need to use right rudder to correct for that and then come back over here. Okay, there we go. And now I have just a little bit of right rudder in, but essentially I'm keeping it the same. So we'll do that. We'll use about 20-degree bank here just to practice. I'm also holding, we've lost a little bit of altitude here and I really want to be at 2,500. So I'm going to climb us back up. And we'll talk a little bit about how to initiate those climbs in just a second. Start to level off. Again, 2,400. Okay, oops, lost my bank. Really want 20 degrees of bank. And again, we're using the horizon for reference and all these things. So the other thing that we're developing is a new picture of what the horizon should look like while we're turning. So it'll be something like that. Okay, and then as I roll back out, again, you notice the ball here swings. So if I am in a turn and I'm turning through, I might need some right rudder, but then as I roll to the left, I also need some left rudder to come back out. So that's that adverse yaw we talked about. Every time the ailerons are deflected, one is generating more lift than the other. That means that the one is generating more drag than the other, and you need to correct that with rudder use. This is one of those things that is particularly tricky to practice in the sim because in the plane you can kind of feel like if you're going into a turn and you're coordinated, you can kind of feel yourself getting pressed correctly into the seat, and a lot of the motion of the plane is more clear, I would say, or at least you get familiar with it. Whereas in the sim, it's sort of like just jerks around. It's kind of hard to get it right. But you can watch the ball and make sure that you're thinking about these things. So anytime I'm initiating a turn, I use rudder in that same direction. So initiating a right turn, a little bit of right rudder, then let the rudders come back to neutral. Hold 20-degree bank. And again, because some of my lift is going into the horizontal plane to turn me, I need a little bit of back pressure. So you can see my yoke, I'm pulling back just a little bit. I said pulling back. I meant just a little bit of back pressure, but not much, just a little. Okay, so we'll take a south heading. I'm actually going to roll out. Let's go back, and I want to roll out on a better visual point. So again, a little bit of left rudder when I start the turn. Back here. And I'm going to use that mountain you can see off in the distance. So it's kind of a little hazy looking, but it's a good reference point. So we'll be at 2,700. As I roll out, a little bit of right rudder. Correct for the adverse yaw. Good. Okay, 2,400. We're looking good. Straight and level flight. Again, to check that, I want to go over here. Look over. Okay, so make sure that my wings level. Good, good. And then my picture looks correct. My instruments match. Everything looks good. Okay, great. So let's talk a little bit about that pulling back in the elevator. For a first flight like this, I would ask the student to really stay below 30 degrees, which also means you don't get a really good sense of what it means to lose that kind of... we'll talk about that later, actually. So you know that you need a little bit of back pressure to keep altitude, and that's good for now. I'm also using an outside visual reference for where I'm flying to, so I'm going to keep pointing towards, I believe that's Mount Amanam. Let's see. It's a pretty nice reference, if that's the one I'm thinking it is, which I think it is. It's easier to tell in the real world. Okay, so now let's talk about climbs and descents. So between each of these, we'll do a climb. I'm sorry, between each of these, we'll do another turn as we're facing the other direction. But I'm going to pause here. Come back over. Let's look at the climbs. Okay, so we're in this section, and we're going to talk about initiating the climb and then leveling off from the climb, as well as particular pitch attitudes to use. You know what? I don't think we need this yet. I had someone yesterday ask about what the different V-speeds mean. You can find those actually all in the POH if you're curious to read more. We won't go into it today. Right now, we're just going to use VY consistent. Actually, we're going to do cruise climbs for this whole thing. Is that really what I want to do? Yeah, that's what I want to do, because I want these climbs to be a little slow, just so we can really practice how to initiate and how to level off. So to initiate a climb, you're going to pitch to, we're going to do V climb instead, which is approximately 7 degrees or 90 knots. Now, again, this is so that you have a reference to what you should be seeing on the instruments when you just confirm on them. But again, you're flying to a specific image, so you want it to look over the cowling like it does every time when you're doing a cruise climb, is what this is called. So you're going to pitch to that specific attitude, apply full power, and then after the airplane stabilizes, so you're going to kind of hold the pitch just using manual control, just kind of holding the yoke where it needs to be to keep the airplane pitched. Once the airplane stabilizes at 90 knots, then you can trim and start to relieve control pressure. Some people will tell you can trim as you're going into it. I think that's also fine as you get more proficient, but it's nice to hold it so you can see how the forces on the plane change and then trim once you're stabilized. All right, so that's how you initiate the climb. To level off the climb, you want to lead it by about 10% of your vertical velocity. We're going to be climbing at about 500 feet per minute, and so you want to level off 50 feet before then. I'll kind of call that out, but if we say we're going to stop at 3,500, we want to start leveling off at 3,450. That gives you a nice smooth level off. Otherwise, you risk kind of jerking the plane down. It's not very comfortable for passengers. And to do that, same thing, you're going to pitch, power, then trim. So to climb, just pitch up, apply full power, and then to level off 50 feet before, pitch to the horizon, leaving in the full power until you gain a little bit of speed, then bring the power back and trim again. All right, so let's go look at that. So back in the sim, and we are going to do some climbs here. So, oops, really close to that mic. Sorry about that. So let's unpause. So again, straight and level flight. We're gonna climb to 3,500, and we want to stay pointed at Mount Amanum. I want to recommend that you put a heading bug in. I think that that's really good practice, even though it is very slow in the sim to wheel this thing around. Okay, great. So there we go, pointed at Mount Amanum, we got it bugged up, climbed a little bit there. Make sure that I'm keeping my altitude correct. I also gained a little bit of RPM, what is up with that? So 2,400 on the RPM, good. Okay, so now to initiate a climb, like we talked about, you want to pitch first, so pitch to the correct attitude, and then you bring in full power, more or less simultaneously, but really it's supposed to be two distinct. Pitch up and then power in. And now as we start to accelerate, I'm finding that I need a little bit more control pressure to keep the attitude I'm expecting. So this is the sight picture I want. Let me make sure that I got this correctly set. Yep, there you go. So that's a sight picture I'm expecting. And I'm currently holding a little bit of back pressure on the yoke, so I'm actually going to trim that out. So you can see the trim wheel in the bottom just kind of going. There we go. All right, so that's what I'm expecting. Now we're coming up to 3,400. At 3,450, we're going to pitch for level. Again, that same flight picture. So 3,450, pitch for level. And then bring the RPM back to 2,400. Okay, great. So landed right at 3,500. And good, we're doing good. Now let's do a turn off to the left. So again, practice our good turning techniques. So the first thing we want to do is lift a wing up, make sure there's no traffic. It looks good. I can tell that I'm starting to climb just because my angle to the horizon was incorrect. And then we roll into it. We're gonna have to counteract adverse yaw with a little bit of right rudder, or left rudder, excuse me. And then I'm gonna do a 20-degree turn. And I noticed that I started climbing there, so I'm at 3,600. So I'm letting my nose come down through the horizon a little bit. I used too much back pressure when I started into the turn, and so I kind of shot right through. I'm still holding about 20-degree bank, and again, through this whole thing, you're scanning for traffic. You want to make sure that you're seeing all those people around you and know what's going on. So, okay, still climbing too much. Sort of interesting. All right, and then we're gonna head back towards Crystal Springs. That's that lake right there, the reservoir right there off in the distance. So again, we need right rudder to level the plane, 2,400, and we want that, oh, that's part of my problem. So we talked about the sight picture, I was using the wrong sight picture again. Gotta remember to be readjusting that. Again, in the plane, you don't have this problem, but it's okay. So we lost a little bit of altitude. Let's go back up and make sure that we're starting where we're supposed to be, 3,500. Okay, there we go. Get to the correct pitch relative to the horizon. Make sure your power is set correctly, which mine is really low. It's 2,400. Good. Okay. And your attitude is correct, your power is correct, and you should get the performance you're expecting. Oops. Okay, I'm going to turn back to Crystal Springs. Rebug this heading bug. Let's see if that worked. Yeah. Wish I could see while I do that. I like that it labels them. I think that's really helpful, but yeah, now I can't really see what I'm doing. Okay. So our heading bug to Crystal Springs. Good. Get aligned here. Let's make sure we're at 3,500. And then we can start a... Okay, let's get to level. So again, we want the sight picture to match what we're expecting. Good. Memorize that picture. We can check our wings, make sure we're level. Good. Good, okay, that seems about right. Yep, good, good. Cross-check the instruments briefly. Looks good, okay. I think we're in good shape. Still climbing a little bit here. But our heading is more or less okay. All right. So let's pause this one and head back to talk about descents. So for climbs, pitch, power, trim. For descents, for constant speed descents, this is the kind of descents we're going to do to get started. 500 feet per minute down. We're going to do power first, and then the plane will naturally pitch down. And so this is where, you know what? To do add image. So let me talk about why that is. The way I would prefer to teach this one actually is to have a model plane, because I could actually show you what I'm seeing, or what kind of show you in a more dynamic way. But lacking that, let's just use the sim and we can talk about kind of what's going on. So at any rate, the series of things we're going to do is power, and we're going to bring it back to 2000 RPM. And then we'll pitch, and you'll find that this occurs naturally. And the reason for that is that the airplane center of gravity is in front of the center of lift. So if we go back to, let me grab another picture here. What I should really do is okay. So if we go okay, you know what? I'm going to do it this way. Just draw a little scratch pad. So we have an airplane, and let's say that we have, maybe it looks like this, and they'll have the wings are kind of coming out towards us. So there's the wings going back and towards us. And then there's the horizontal, I'm sorry, the empennage we talked about yesterday. It was a pretty bad airplane, but that's okay. And then maybe this is the front. We'll have one wheel in the front, and then we got our two wheels in the back here. Okay, so not the greatest airplane ever, but what's important from this picture is that the lift that's being generated comes from the center of the wings, more or less up like this. But the weight of gravity, the center of gravity is forward of that. It's like that. And so if you were to slow the airplane down, there would be less lift. Can I copy? That would be just so handy, wouldn't it? That's right. So if you were to slow the airplane down, so again, we'll quickly draw our little tail and our wings. So if you slow the airplane down, then you're generating less lift, so little lift vector here, but the gravity is still the same. And since there's a distance between these two, that's going to cause the airplane to pitch forward. And so it actually starts to naturally descend without you having to do anything else. So let's look at the sim and see what this looks like. Well, let me, yeah, so we'll look at what that looks like. Again, you can trim to relieve the control pressures. I typically find that when you power back to 2000, it just kind of flies itself down really nice. You don't have to do anything else. And then to level off, you're going to bring in the power, and then pitch will occur naturally, and then trim. So the same sort of thing where we're talking about before, you have less lift after you reduce power down below here. If you then bring the power back up, it rebalances and the plane will fly straight and level again. And so you don't really have to change anything on the controls. And for the most part, the trim just stays the same. So it's kind of a nice way to just do a real easy descent. Okay, so let's go back to flight sim here. Let's see if I can show this in some sort of meaningful way. So I'm going to unpause the flight and try and look at the airplane from the side. And you'll see we're climbing a little bit, so we're not quite level with the horizon. But this is the... Actually, I think there's some way. Let me look at those. Let me see real quick. I'm going to spend exactly 1 minute on if I can get this to show the... forces acting on the plane, because I know they model all of that, and I'm wondering if that's something readily available. I don't think so. Maybe in developer mode. Okay, well, I will look into that later, but for now we can at least do this. So, pardon my not quite level flight. What I want to show you is watch the engine over here. So we're at about 3,400 or 2,400 RPM we want to be. If I bring this back to 2,000, the engine come back, you'll notice that the airplane starts to pitch down naturally. So it's already starting to descend a little bit considering the speed. And you see that the nose actually did come down a little bit through the horizon. So we're still a little high. I want to be at 2,000. So I'm going to bring this in. This is the needle that I'm looking at. Okay, there we go. So now you can see that the nose is dipped below the horizon. We're starting to descend. We're actually descending at 500 feet per minute. That's exactly what we want for a nice kind of cruise descent. If I went more aggressive, let's say that I just went to, we can even bring the engine full out just to kind of show. So you see how the nose dips even more. And that's because that center of lift is behind the center of gravity again. But if I brought power all the way back, so we were at 24,000 RPM, if I bring it back to 24,000 RPM, then all of the forces of the airplane will again be balanced and the plane will come back up and rise up to basically the same attitude we were at before. Because we gained a bunch of airspeed while we were descending, it's sort of overcorrecting, so I have to give it a second to stabilize. This is also why you don't necessarily want to trim right away, because the airplane needs to stabilize itself. But once it does, then we should be right back to a level flying right around here. Okay, so again, to then do that maneuver as we're coming into Crystal Springs. So we're at 3,000 feet, that's okay. Let me climb up to exactly 3,000. Again, a little bit of right rudder to initiate the turn. Ball's sort of swinging around a little more than I'd like. That's the slip skid indicator down there, the step on the ball thing. Okay. 2,400, and all right, I'm gonna initiate a descent. So again, I bring the RPM back to 2,000, and the plane shoots. All right, we just had a couple neighbors stumbling, not stumbling, but just kind of walking around the other way, and a dog got kind of excited. But anyway, so you'll see that I brought the RPM back to 2,000. Plane started naturally descending at a nice 500 feet per minute. That's pretty nice for passengers as well. So typically that's what I would recommend for a cruise descent. Nice one to plan around. We're going at about 110 knots. That's also what we expect to see for this descent. So everything here looks really good. Nice, clean, stabilized. I'm banking a little bit to the right just to keep aligned with Crystal Springs. It's better for this flight as a first flight that we practice all of these things just in straight lines back and forth, and turns are turns, we don't mix them. So I'm just making a mental note of that. Now 50 feet before, I'm just gonna bring, oops, I shouldn't be banking. I'm gonna bring power back up to 2,400. And again, the airplane will just automatically correct itself back. I brought in a little bit too much power, so now we've started climbing. Okay, so I'm sort of, there we go, 2,400. All right, great. So 3,500, looking good. Let's turn back to Mount Amanam. So again, first thing we do always, we look under our wing, make sure there's no traffic, lift the wing a little bit, make sure we can see. And then a little bit of right rudder to initiate the turn. Try and keep the ball centered. We'll go for a 30-degree bank turn this time. And after we initiate the bank, we might need a little bit of right rudder. We can always check the ball. We don't need as much. Now, I started to climb again there. So my sight picture for this turn isn't great. You do want to have a sight picture of what 30 degrees bank looks like and be able to kind of hold that picture in your head. All right, that first mountain peak there is Mount Umnam. Again, I climbed up a little bit there. That's not what we're looking for. We want to keep it level through that entire turn. I was using too much back pressure for it. But we'll go from 2,700, we'll use that as a starting point here, back to Mount Umnam. Maybe good to reset your heading bug to point the other direction. I do think that's a really good habit. Typically, if I was with a student, I would go and set that for them so they don't have to multitask in that same way. So I'm going to leave it back here, but we do want to fly towards Mount Umnam using our visual reference cues. All right, my picture looks good. This is what I'm expecting for level flight. Again, I can check my wings look a little bit off. Okay, good. So I think I'm banking a little to the right. Oops. And sure enough, if I look at my instruments, I am. Okay. So make sure I'm staying level there. Good. Okay, we climbed up a bit. So let's do another climb. So we'll climb back up to 3,500. So again, pitch, power, trim. So I'm going to pitch up to the picture I expect, which is right about there. Bring in full power. And then I'm holding that same pitch attitude. Let the plane stabilize at the attitude it's going to be. And so, good. So it seems like it's stabilized here. And so now I'm trimming out control pressure. So I don't have to hold anything on the controls. The plane will just fly itself through this. And then at this point, the flight instructor can dramatically take their hands off the controls and show the student that it actually will fly itself pretty naturally. I'm a little slow. I want to be about 90 knots. So again, I'm trying to hold my picture and then using the airspeed I'm seeing to correct for minor things in that picture. Okay, 3,500. And we want to level off 50 feet before 3,500. Again, find our level picture, let ourselves accelerate back up to our cruise speed, and then bring the power back to 2,400. Lost my heading point a little bit, so I want to turn back to Mount Umnam. Good. All right, and now we're level at 3,500. We can do another descent. So to do that, we're gonna bring our power back to 2,000. Let the plane naturally pitch down. Overshot it a little bit there. And we're hoping to see that it comes to about 500 feet per minute. Okay, we want to keep our heading more or less constant here. Not more or less, we really want to keep our heading precisely constant. It just takes some practice to get to that point. So now the plane wants to rise up a little bit. I'm kind of helping get to that 500 feet per minute. Since I'm expecting 110 knots, my trim's a little off, so I just trim down just to make sure that I'm getting that performance I'm expecting. All right, and I am totally hands-off on the controls right now. Kind of nice, all right, a little bit to the right. All right, so we're coming up on 1 o'clock. That's the core of the lesson for today. Thank you for putting up with a couple of those missing images. I will have a couple of better resources for next time, at least things I can draw on real quickly. Obviously, in a real flight, we would then fly back to the airport. Since we're in the sim, we can just sort of end here. I'll stay on a little bit longer past 1 and get us back, and we can talk about the landing procedure and stuff if you're curious, but we'll close out the lesson here. We do a little pause break, and I'm going to go to back to the Mac here, talk about a couple of common errors. One is forgetting to scan for traffic. Talked a little bit about this before. This is really important and something that would be pointed out to the student a lot. Over controlling is another one. You don't want to be gripping the yoke really hard. It's really just pressure on the surfaces. You're not trying to move it in the same way. Really, really light. The plane is kind of set up so that you shouldn't need to force the controls in any kind of way. Chasing the instruments is another big problem. This is something I'd be looking for if I had a student with me. So if they're over-focused on the airspeed indicator, they're not flying the attitude relative to the horizon. They're not looking at the sight picture, what they're seeing outside of the plane. Instead, if they're trying to get the airspeed to do a specific thing, that can be a problem. You end up chasing it and it goes up and down, and you can never quite get it right anyway. You really just want to fly the right attitude. Other one is too firm a grip on the controls. You want to use fingertip pressure. Again, that's kind of similar to the over-controlling. And last but not least is lack of rudder coordination. So that's especially during turns to make sure you're using rudder. Completion standards. So you must be able to use external visual reference to maintain appropriate pitch and bank attitudes with occasional cross-check of aircraft instruments. Must develop a visual scanning of traffic and check for traffic before maneuvers. ACS standards 10 knot, plus minus 10 knots, plus minus 10 degrees, 100 feet. Okay. Required homework here. If you'd like to do it, sign up for a ground school if you have not yet completed. West Valley Flying Club, the one that I'm a part of, has a ground school as part of the club. I used Sporties for a lot of my training. I really like Sporties. So if you're looking for a good online one, that's another option. There's tons of good suggestions online, so just poke around and you can find it. You can also find the Airman's Airplane Flying Handbook and the Pilot's Handbook of Aeronautical Knowledge. These are FAA resources, really, really good. They're a little dense. I really like the presentation of Sporties, but you could just read them through as a textbook and you'd be in really good shape. Recommended homework, if you have a little bit of time, is to chair fly the 4 fundamentals. So hop in the simulator or just visualize if you don't have a simulator, or if you don't want to go through the whole simulator process. And when you're chair flying them, you really want to be thinking about the order of events of what you're doing for these. So, when you're straight and level flight, you're looking for that picture, you're checking your wingtips to make sure you're level, initiating the climb, pitch power trim, and then again to level off, pitch power trim. For descents, then it's power pitch trim, again, power pitch trim, where the pitch kind of occurs naturally. All right, that's all I got for today. Thanks everyone for joining. I will see you tomorrow, same time. And again, I'll try and keep it to about 2 hours every time. Hopefully get better each lesson. For today, I'll stay a little bit longer. If you have any questions, feel free to throw them in the chat or on Discord later. Both work just fine. Actually, I'll post the Discord link in the chat if that's useful to anyone. And yeah, I'll be around for just a minute longer while I get us back to Palo Alto. All right, thanks. All right. Heading back to Palo Alto. So let's bring this plane, and we can call again and get the latest ATIS. And since we're out of the lesson and just having fun, let's put on... I can't do that. The weather here is better, but it's probably still pretty bad. Let me see what it is at Palo Alto right now. Oh. Yeah. It's not great weather at Palo Alto. No, that's okay. We can use San Jose's weather. So there's 2,500. Again, we want to bring our power up 2,400 RPM. That should bring us back to level flight. And I'm going to put in... Oops. Okay, so make sure my sight picture looks good. Okay, and I'm actually going to do a pause break here. So I'm going to put in San Jose's ATIS, and we can use that for our reference of what they're saying the weather is currently in the game, at least, since it's not the same as what it is outside. Okay, so 126.95. I just looked this up on my ForeFlight app. Then I'm going to put it on the COM2 radio, and let's see if we can get it read out here. Okay, yeah, so... actually, I'm not sure. Yeah, I have ATC voices turned off, but we can read it here just to talk about it. Okay, so altimeter 2 Niner, Niner 2, we already have that set in here. They're using runway 30, so that bodes well. Then we're probably using 31 at Palo Alto. Of course, we would get actually Palo Alto's information if it was modeled in the game. They treat Palo Alto, Microsoft Flight Sim treats Palo Alto as a non-towered airport, so that's why it sort of has some weird things like not having an ATIS. Just letting the ATIS go through. Okay, advise on initial contact, you have Bravo. So that's the, typically we've been out for about an hour. We probably would have had one new ATIS. It's probably Charlie at Palo Alto right now, if I was gonna guess, just a guess. We could look at the time and make a more informed guess. It might be Delta by now. Oh, come on. It's not gonna cycle through again. Alright, well that's frustrating. Well, the good news is, so if it was a real ATIS, we'd be able to just listen to it through from the beginning again. Because of the game setup, it's just not letting me do that. But we know what the weather is here, because we can look at the wind layer. And we have 1 knot of wind at 270, so essentially calm, should be good to go. I'm going to bug in Palo Alto so that we have directions to where we're going, just to make this simple. Interesting. Okay. And then once I have it selected, I can hit direct, enter, enter. This is one of those things that works differently in the sim. I wish it didn't. Okay, so now we have it bugged in. It'll show us navigation over to the airport, which is sort of a nice reference. And then we can go back like this and pop up. Okay. So I'm doing that same cruise descent that we talked about earlier today. And I am too far to the left. Palo Alto is kind of over this way. So we'd call Palo Alto up, maybe something like Palo Alto Tower, Cessna Alpha Lima Tango India Sierras at 2,500 over Slack is probably where we are. Ground actually, just see. That's right over there. Over Slack, inbound with Bravo. And then they're probably going to say something like, since we're coming from a weird direction, they're probably going to say something, depending on how busy it is, they might give us different directions. So they might say something like, enter left base or left base runway 31. They may send us a little bit further along. It just sort of depends on what the rest of the traffic is. But let's assume that they said left base 31. Traffic for left pattern here is 1,000. Also, if you're new to flying, I know I'm saying a lot of things that are sort of probably not really helpful information. So this is, I'm kind of treating this as outside of the lesson bonus stuff. Yeah, okay, so pattern altitude for the left traffic here is 1,000. So trying to get to roughly where the left base is and get down to traffic pattern altitude. We're below 110 and we're roughly a beam where the numbers would be, so I'm going to drop my flaps to 10. Entering the airspace, so I'll do a GUMPS check. Gas, good. Undercarriage is welded and my brake seats work. Mixture is rich. Prop is fixed. Switches, we'll turn our landing light on for landing. And seatbelts and switches, so everyone's got their seatbelts on. Okay, coming in here, a little bit of our base. Now, one habit that's really good to get into is to bug this up to the runway heading so that you can confirm that you're on the right heading. Come on. There we go. So now we're turning base. Turn base, we want to be at 70 knots airspeed, so I'm a little fast here. 1,500 RPM is usually pretty good. Again, I'm looking out my window. I want to make sure that I'm lined up with everything. Okay. Oops. 70 knots, 1,500 RPM, good. Again, I want to roll into final here cleanly. This is where I wish I could kind of duck my head around like in the real world. But that's all right. Oops, come on. There we go. Low fuel indicators. All right. And then 500 feet AGL, that's all right. Where is my runway? Okay. My last notch of flaps. Oh, I way overshot that. How did I do that? Okay, well, that's all right. So we're gonna go 65 knots for final. I'm coming back to the center line. That was a truly atrocious approach to final. That turn was way late. So, yeah, okay. So I'm looking to see red, white on the left and a red on the right, which I do. Again, 65 knots I'm looking for with full flaps here. I'm gonna turn back the other way a little bit too much. Thanks. Okay, a little too high here. So we want to pitch for airspeed and power for altitude. So I'm going to bring back some power here. But I like my airspeed. Okay, this is probably good. There we go. We want to be on the glide path. And I'm watching the beginning of the runway kind of growing bigger in my... all right. Line a little better with my center line. Good. Bringing back power. And leveling off on the horizon. Wow, that feels like I'm going really fast. I wonder if that's an artifact of my camera settings. Wow. All right, well, come back to centerline. I'm sort of annoyed at myself because that felt like it was really, well, one, it was a really rough landing, just as far as like alignment. Landings in the sim are kind of notoriously tricky, so I give myself a little bit of latitude on it. But I'm trying to figure out why that was, and I think it might be because to get a view of the cockpit that has all of these instruments, like the standard one that the flight sim kind of recommends looks more like that, right? And so I'm wondering if I'm just seeing more of the world passing in a way that I wasn't expecting. Kind of visual cues lying to me. Anyway, okay, I'll get off the runway, do our cleanup flow. Good. So reset our trim. Trim is in the right spot. Mixture for taxi, which we know now. We found this from earlier. Good. Reset our flaps. And turn off our landing light. And now we run our finger over the checklist, make sure we didn't forget anything. Let's do that. All right, great. And then taxi back to our parking spot. So we call up tower, or they'd probably say something like on Zulu contact ground. And we'd switch over to the ground frequency, which is 125.0. Palo Alto ground, Cessna Alpha Lima Tango India Sierra on Zulu taxi back to Romeo, which was the road that we were on. So then they'd say probably something like taxi Romeo via Zulu Yankee, or taxi via Yankee 2 suggest Juliet Romeo, kind of the standard flow that they would give us. And that's because they kind of keep a counterclockwise movement of aircraft. So we come in on Yankee and usually leave on Juliet for where we're going on the airport. I'll try this real quick and see. Yeah, interesting. I was just wondering if the relative motion was, so I'm not changing my speed at all as I'm taxiing. So this speed and what it looks like out the window versus that speed and what it looks like out the window. Okay, well, maybe I'll need to do that a little differently for landing. In fact, maybe that's a good thing. I'll have to look at it, but okay. So anyway, it's sort of interesting because the trust your airspeed is a good lesson if you want to do mountain flying, because when you're flying at high density altitudes, your airspeed indicator will still be the correct speed to fly, but your speed over the ground will be much higher than usual. And so it feels like you're moving really fast compared to what you normally are. And you actually are flying really fast over the ground, but you still need to fly the correct airspeeds. So just sort of a good... okay, so I'm checking under my wings, make sure there's no traffic. Oops. Yeah. Come on, cameras. Okay. Yeah, I love when they bring the fire trucks out, just in case. So another thing I'm noticing that I really don't like is this low fuel level. So in leaving, we had planned for enough fuel for the flight, so we knew what we had when we were going. And even our indicators still say that we have already, 5 gallons of fuel on each side, which is enough for another hour of flight. So we're landing okay. But anytime you have an annunciator come on, this should be a red flag that's something of note or concern is going on. So just being aware of that. All right, I'm gonna pretend like I am parked on Juliet and saying all the way back to Romeo, so stop here. Do my after landing securing the airplane checklist, parking brakes set, electrical equipment autopilot off, turning off everything except the beacon, turning off the avionics. Make sure I didn't miss anything else on here. Do a grounding check, we'll go, this will shut off the sim. Let me see if I can fix that real quick actually. There's a way to do it. Sorry about that. Dog's getting excited. All right, well, we do the grounding check, turn the magnetos off and on. Just to make sure that the engine quits. I'm not going to do that because that'll end the sim. Bring the throttle to, oops, should have had it at 1,000 this whole time. Up to 1,000, idle cutoff. All right, there you go. And then it's ignition switch off, master off, and fuel selector valve on the bottom to left or right. All right, great. Thanks, everyone. Have a good rest of your Thursday, and I'll see you tomorrow for our next lesson, which will be airport operations, ground and tower communications, ground ops, and light gun signals. Should be pretty fun. See you then.